The webinar today will be exciting. It's about one of our new products called the NaturaSpec. So this is a new NIR spectral radiometer that we've just launched. We'll start with a few words about Spectral Evolution, just to highlight what the company does. And then we'll talk about the challenges of field spectroscopy and the reason why we really developed a new instrument to address those challenges. We'll talk, of course, about the features of that instrument, and then we'll go over an overview of some typical application examples for remote sensing scientists where this instrument may be helpful. So Spectral Evolution is a company that was founded in 2004 and is now one of the leading manufacturers of high-quality UV visible and NIR spectrometers and spectroradiometers. So the spectral range that we are addressing with our instrument is roughly from 350 nanometers to 2,500 nanometers, which is a range that goes from the ultraviolet to the infrared. We are an American company. We are located just outside of Boston, Massachusetts. And all of our instruments are designed and manufactured in our facility. And they are distributed all over the world through a vast network of representatives and distributors. Some of the hyperspectral applications that we're dealing with, remote sensing, which is a very wide term, but it pretty much tells you that we are doing sensing of samples without touching them. That's the real definition of remote sensing. So it's non-destructive sensing of samples, which can be vegetation, minerals, but also materials, pharmaceutical products, etc. Our specialty is instruments for the field, so ruggedized instruments to be used outdoors on field campaigns. And we also have a line of laboratory instruments that are used in photonics labs to do radiometric calibration transfer, for instance. But today we will be focusing on really field instruments and applications of field spectroscopy. So when we think about field spectroscopy, we think, of course, about field conditions. We now have to take a scientific instrument in the field. So what are the challenges of that? Well, there's multiple challenges. First of all, we're dealing with an environment that is not controlled. We don't have the luxury of a laboratory where the temperature is controlled and we can go at our own pace, our own schedule, follow lab procedures. We are now in the wild, we're in nature, and we have to deal with changing environmental conditions. We have to deal with the amount of sunlight coming in that is going to vary, from minute to minute, because there may be a passing cloud or the sun may not be at its zenith anymore. And so all of this is going to affect the data of a spectroradiometer. We're dealing as well with reliability issues because field conditions are more rugged. So, and we may be remote as well. We can do field campaigns in very remote regions of the world where if your instrument breaks, well, you don't have the luxury of being able to repair it. So you need very good reliability on the instruments. The stability and the repeatability of the data is important. With all those varying factors, how do we ensure that we're going to have measurements that are going to be repeatable and measurements that are going to be stable, throughout the campaign? So field campaigns present other challenges about the portability of the instruments. You can see a picture here of a typical remote sensing field campaign where people will bring hyperspectral cameras, they will bring tarp, hard hat, boots, everything that is needed for a remote campaign. And it's a lot of instruments. So all this workload that has to be carried to the field matters. So we need to think about portability, the light well of the instrument. Although we're typically dealing with a limited schedule. We don't have the luxury of doing a field campaigns for months and months. We may have just 1 week to gather all the samples we need. So the speed of acquisition of the measurements is very important. The complexity or the simplicity of the setup and the use of the instrument is important, as well as the connectivity and the power requirements of the instrument. So all of those factors are going to really impact the life of the scientist in the field. So at Spectral Evolution, we, with all the experience we've had accumulated over the years, we decided to look at, okay, what would be the best instrument to really address all of those issues and make field spectroscopy a little bit easier. And of course, the big question is, with all those challenges and all those requirements, how do we keep the quality of the data on par with lab data? Most instruments that are made for the lab are not portable. They are not made to survive in the field environment. So how do we come up with a field instrument that has all the quality of a lab instrument but can be used in the field? So that was really the big challenge for this instrument. So let's review the NaturaSpec instrument. So as far as the ruggedness, the reliability, portability, stability of the instrument, so our technology is based on solid state detectors. So what that means is that those detectors have no moving parts. So whether it's in the optical path or in the electronic box, there are no moving parts in our instruments, unlike many other spectrometers that have moving gratings. So what that means is that no moving parts mean no motors, no parts that can come loose. So we have a very stable and fixed optical path and electronic system, which is of great advantage to survive under shock and vibrations that may occur in the field. So the reliability of our instrument is very high from that standpoint of being rugged. To address the variability of temperatures in the field, our detectors are cooled. So they're precisely cooled with thermoelectric modules to make sure that the detectors are going to operate within their sweet range, the optimum range for the detectors, and that the data will be repeatable from measurement to measurement. Our instrument, although comes in a metal enclosure, aluminum enclosure, which is powder-coated. So very strong enclosure to resist shock, vibration, scratches, and so on. Powder-coated to resist corrosion. And the optical path and the electronic path are in a dust and humidity-proof enclosure as well. So we can now operate, in field environments without having the worries of the instrument failing because, today it's too humid or too hot or too cold. So we have a picture here of an instrument in snow, which living in Massachusetts, we get an abundance of snow. And that picture was taken just a couple of weeks ago when we had a big snowstorm and we decided to do measurements out there. So this is not a Photoshop picture. That's how we use our instruments here in the wilderness. For portability, the NaturaSpec although has a handle, so a high impact plastic handle on top, which makes it very easy to move not only from side to side, but if you're using it in the lab, you could move it from one table to another table or from one room to another room. And our instruments come as well in a backpack, a custom-made backpack. So they are very portable in the field. They come with high-capacity lithium-ion batteries. So those custom-made batteries last for quite a long time. So under typical field conditions, taking measurements nonstop, your battery will last about 5 to 6 hours, for typical measurements. So with 2 batteries, you can cover, more than 1 day of data gathering in the field. And to reduce the clutter of wires that are okay in a lab setting but not in the field, we have a Bluetooth connection. So the instrument is operated from either a tablet or a laptop via Bluetooth. So there is no wire between the the controlling computer, and the instrument. So let's talk now about, we've seen that we have a rugged instrument, but the question was, how do we get lab quality data in a field environment? So most people know about spectral resolution. So the spectral resolution of a spectroradiometer or spectrometer is very important, because that is giving you, if you're looking at your spectrum, how fine that instrument is going to analyze that spectrum. So if you're thinking about your spectrum being sliced and diced into little increments, that spectral resolution, the smaller is going to be the number, the better the resolution is. In order to have a high spectral resolution, we change the detectors on the NaturaSpec compared to other instruments that are out there. So we actually double the number of elements for each detector. So overall, we have 2,048 elements covering the complete range of 350 to 2,500 nanometers. So that gives us a resolution, a spectral resolution that's really good, of 2.7 nanometers. So that's in the UV-Vis range, which the UV-Vis range goes from 350 to 1,000 nanometers. Then the 5.5 nanometers is over what we call the SWIR-1 range, which is the shortwave infrared 1 range, which goes from 1,000 to 1,900 nanometers. And then the SWIR-2 range goes from 1,900 to 2,500 nanometers. So that spectral resolution is very good and is better than any other instrument out there on the market. That's one way to address spectral resolution, but spectral resolution is not everything in a spectrometer, because you can have good spectral resolution, very fine spectral resolution, but very noisy data, which we don't want. We want good, clean data with a minimum amount of noise. So here we're going to talk about what we call signal-to-noise ratio. We want the data to be not only precise, but we just want the data. We don't want all the noise, all the pollution that goes with the data. So how did we address that? The big factor in a spectrometer is that it needs light to operate. So the better the light signal is going to be to the system, the better data you're going to have. If you're trying to use a spectrometer in the dark, you're not going to get any signal. If you're using a spectrometer under very cloudy or rainy conditions, it's going to be very dark, and your spectrometer is not going to react well to that, because it needs light to get into the detectors. So that light comes through the fiber optic cable. So the fiber optic cable is really the conduit that takes the light signal from your sample to the spectrometer and the detectors. So the first thing to address is really that fiber optic cable. How do we make sure that we have the best fiber optic cable out there that is going to conduct the light without any loss of signal? Well, the design of Spectral Evolution's instruments is that the whole signal goes through every single detector. So the detectors are really in series in our system. So for people that are familiar with other spectrometers, what people may do is that they have one fiber optic cable going to the instrument, but then this fiber optic cable is split into 3 different cables for each detector. By doing that, you really diminish your signal to each detector. So our design is different. It brings the complete signal to the detectors. The way we do that is that the fiber optic cable of our instrument mates directly with the entrance slit of the spectrometer. So there is no division inside the spectrometer. The complete signal passes through each detector. So our signal is very high going into the detector. Another factor that is important in a fiber optic is all the fiber optic cables within that fiber are they all contributing to the signal? Because a typical fiber optic cable has about 60 fibers. So we want to make sure that all 60 of those fibers are bringing the signal to the detectors. So in order to do that, you can see a picture in the upper right corner here where the fibers are terminating into a slit, and that slit matches perfectly with the entrance slit to the instrument. So instead of having just a round circular bundle of fibers, we actually are directing every single fibers to that slit. So we are ensuring that there is no loss of signal through that fiber. Another advantage is that we are not using any coupling between fibers here, so there is no attenuation because of couplings. Every time you have a fiber optic attached to another one, there is a loss of signal. Here we don't use that because we have again, the direct mating of the fiber to the spectrometer. And because this fiber is precisely machined and aligned with the entrance slit to the spectrometer, we don't have any loss of calibration if we remove that fiber from the instrument. So that's one of the big advantages of a spectral evolution instrument that we'll see a little bit further down, is that if your fiber was going to break, you can actually remove it easily, replace it with a fiber, and not lose any calibration. So by doing this, paying attention to the fiber and paying attention to how the signal enters the instrument and goes through each detector, we are able to achieve a very good signal-to-noise ratio. So for people who want to check the specification, we express the signal-to-noise into noise equivalence radians. And those numbers, as you can see, are very small, in the 10 to the -9 range. And you can compare that with other instruments on the market. You'll see that those numbers are very, very good. So what it means is that when our spectrometer sees a light signal coming in, it's going to get the best signal possible based on that and the less noise. Other things that we do to optimize that signal are through the software. When you take measurements with a spectrometer, there's a few things that need to be done. You have to compensate for dark current. So what you do typically, you would take a scan of a very dark sample, so meaning no light. And whatever signal you get on that dark sample is really your noise, because theoretically, if you're in the perfect dark without any light signal, you would get no signal at all. But in reality, you do get some noise, even with a dark sample. So our program will compensate for that. And the interesting thing with the NaturaSpec is that this dark current correction is done automatically. So there is a shutter in the instrument that with every single scan you take is going to compensate for that noise, for that dark current noise. So you never have to worry about that. It's done automatically. There's no optimization step for dark correction. And same thing with the exposure. Each detector, being in a different spectral range, will react differently to the light signal. And in one particular range, you may need more exposure to the detector, so a longer time for the detector to be illuminated than in another range. Our software is clever enough to decide what is the best optimum exposure time for each detector independently. So by doing that, you're going to make sure that not only you have the best signal-to-noise ratio for each detector, but you have the best signal-to-noise ratio overall for your complete spectral data. And because each detector is treated independently from an exposure standpoint, you make sure that, if you're looking at for instance, a very light sample, you will have very high signal-to-noise ratio in the UV-Vis region, because you have a very light sample. So let's say a lot of reflectance. But in the NIR region, you may be too dark. Well, our software will automatically adjust that. As far as the averaging for each scan, so we have two modes for that. You can either tell the instrument to automatically take the optimum number of averages for each detector. What an average is that when we take a measurement, it's actually an average of several measurements. So it's just not one scan and we're done. It's like 10 scans, 20 scans, or 40 scans. And the reason for that is that, the more data you get a better statistical distribution of the signal and a better average and a better approach of the signal to the real, what you're really measuring. So you can either input this manually if you want, let's say, 20 averages for every scan, or you can let the software do that for you and optimize it directly. Most customers we have use the auto averaging feature because it really makes life a lot simpler, and then you make sure that you get your optimum exposure averaging time for every single scan. All those little optimization features make the NaturaSpec the instrument with the best signal to noise ratio on the market. It not only has a very high spectral resolution, but it has very good sensitivity as well. So you get accurate data, but you get accurate data that is not polluted with a lot of noise. And by having those auto optimization feature, you make sure as well that you have repeatable data. One sample to another, you'll have repeatable data. And that's especially very important for universities, because you may have several operators using the instrument. You may have several students going on field campaigns, and from one student to another, there may be variation in how they want to use the instrument, how they set up the instrument, the distance from the target, and so on. By having those optimization features, you kind of make sure that all the data is going to be comparable, from operator to operator. Another thing about that, those auto optimization and auto averages, is that ensures that you have the optimum acquisition time for each sample. So that means that by doing that, you will have a quick acquisition time, and you won't have to wait, 10 seconds to get a scan. I mean, when we use the NaturaSpec, depending on your number of averages, it's going to take anywhere from 1 second to 3 seconds to acquire spectral data. When you're on a field campaign, you're going to gather thousands of data points per day. The acquisition time is very important. The NaturaSpec comes as a bundle. You not only get the instrument with the fiber optic cable I was talking about, which is precisely made to match the slit of the instrument is included. It's a 1.4 meter fiber. The Darwin acquisition and visualization software is included, but you also get a whole lot of accessories that are helpful for the field. So you get the high capacity batteries and charger. You get what we call a pistol grip fiber holder. So that pistol grip allows you to precisely hold the fiber, and if you're pointing at a very specific target area, you can then set that pistol grip on the tripod, make sure you have the correct angle that you want compared to your target, etc. It comes as well with a white reference plate. So that white reference plate is like a spectral plate, 5 inch by 5 inches. It has a theoretically 100% reflectance. So what you would do when you take relative measurements in reflectance mode is that you first take a scan of that sample plate, which will be your reference, telling you that's where my signal is at 100%. And then you take your sample measurements, that are going to compare to that white reference. And then the instrument comes with a custom bypack that makes it very easy to carry the instrument in the field. And you also get a Pelican case, which is a hard shell case that's suitable for travel, through plane and checking the instrument on the plane. So all of this is included in the NaturaSpec bundle. So it's really, I would say, the minimum accessories that you need, to really start remote sensing in the field. And then we have, of course, a lot of different accessories that are compatible with the instrument. I'm going to go over some of those applications now and describe some of the accessories. So before we do that, let's go back to the original challenges that we had. So as far as the control environment, the requirement of field campaigns, needing lab quality data in the field. So those were our goals. So how did we address that? For the uncontrolled environment, we talked about the ruggedness of the instrument, being a metal enclosure, having fixed optics and electronics, being weatherproof, having the optimization features that ensures repeatability. So we've addressed the uncontrolled environment issue. Then for the needs of the field campaign, as far as the portability, the accessibility, connectivity, and so on, we've addressed that as well with the portability of the instrument. So the instrument, just for reference, is about 5 kilograms. It can be easily carried, by hand or in the backpack. It's battery operated with a high capacity batteries, so that addresses, the requirements of being operating in the field. The Bluetooth connections ensures that you have, no clumsy wires all over the place when you're in the field. And then the optimization features and the simplicity of operation are extremely important in the field, because you don't have the luxury of, setting up very complex setups in the field. You want to be up and running very quick. When you take one of our instruments in the field, all you have to do really is turn your computer on, turn the instrument on, and then start scanning. I mean, the optimization is done automatically. So it's really big time savings compared to other instruments that are exist out there. And as far as, one of the big challenges, which was how do we get lab quality data in the field? Well, we've seen that we have high resolution because of, the detectors we're using, but we also have the high sensitivity. And that's really, I think, the takeaway of that presentation is that finally on the market, there is an instrument that not only has high resolution, but has good quality data as well, without a lot of pollution. Based on these goals, we can see that really the NaturaSpec is a new standard for remote sensing scientists. So it really brings NIR spectroscopy to the field to a new level of quality data. And as everybody knows, data, hyperspectral data is getting finer and finer. Satellite data is getting finer, and hyperspectral cameras are getting finer as well. So it's normal that for NIR spectrometers, we also need to go to the next step and finally bring an instrument that has a higher resolution, good quality data as well. So let's talk about one of the big applications of field spectroscopy, which is remote sensing in general, but vegetation particularly. So what type of analysis can you do with the NaturaSpec? Well, you can do simple analysis like classification and identification of vegetation, of plants and trees. Crop science is a big candidate for NIR spectroscopy, where you're going to be looking at your crop health, the fertility of your plants, looking at the plant science, water stress, red edge of plants, water content, chlorophyll content, lignin content. All of these are very important to vegetation scientists. Biomass research is another application. Environmental research as a whole, pollution, impact of pollution on vegetation and the climate. Forest canopy studies. So those spectrometers are used a lot for that. Invasive species, whether it's plant species in forest or fields, or even algae in water. So all of those are typical examples and applications of our instruments. On this particular slide, is an example taken with the NaturaSpec of a leaf reflectance sample. So you can see a typical vegetation curve here, going from 350 to 2500 nanometers. To take those samples, I was telling you earlier that we have many different accessories that can be useful. So the base NaturaSpec bundle comes with a fiber optic cable which has a 25-degree field of view. So what that means is that the field of view of that fiber is a cone, and the full angle of that cone is 25 degrees. The farther away you will be from your target area, the bigger your sampling area will be. And as you get closer to your target, your sampling area will get smaller. So that is a bit limiting, if you want to do measurements at the leaf level. So what we propose for the leaf level, we have a leaf clip. It's a probe that has a built-in light source and that connects directly to the fiber optic. And that probe can then take direct contact measurements of a leaf. So it's the picture in the upper right-hand corner. We also have reflectance and transmittance spheres, RT sphere, that can do, just reflectance and transmittance. But the advantage of that RT sphere is that it is field portable as well. Most spheres that are out there are for lab use only, and this one is actually portable. So another advantage of the NaturaSpec and the accessories is to really bring that lab quality data to the field, because now you really have a lab setup of a spectrometer and a sphere, but you have that setup in the field. You would get extremely good quality data with a sphere in the field. And then the pistol grip that I was describing earlier, which is used a lot for like forest canopy measurements. If you're looking at targets that are kind of far away, if you want to cover a big area, then you use your bare fiber, or maybe a bare fiber with an optic, like a lens that would reduce your field of view. All of those accessories are manufactured by Spectral Evolution and are compatible with the NaturaSpec. If you already have a Spectral Evolution instruments with existing accessories, all those accessories are backward compatible with the NaturaSpec. So that's one of the big advantages of our instruments as well, is that every accessory is compatible with every spectrometer. Another big application we have is soil and mineral analysis. Soil science is a huge deal for agriculture, and there are a lot of institutes and universities doing some soil science, and soil fertility is very important. Pollution, soil contamination is another big topic. Mineral identification is of interest to geologists and mining companies. So is iteration mapping, looking at how minerals are being altered in the field, because the iteration of minerals will give you an idea of where to mine and where to drill for specific ores. Ground truthing. So ground truthing is validation on the ground of either satellite data or drone data or hyperspectral camera data. Studies of water bodies is important for ground truthing. Albedo measurements is another one for ground truthing. Drill core logging for mining companies. So all those applications can be done with a NaturaSpec on the ground. So for that, we could use contact probes or bare fibers or different for optics. And the interesting thing as well with this NIR spectral data is that the accuracy, the resolution is so good that you can actually use that in conjunction with chemometrics to create a chemometric model that will then give you quantitative data based on your NIR data. In other words, instead of just looking at your spectral data, you are able to use that with a chemometrics model to tell you how much of a particular element you have in the data. So for instance, with soil, you will be able to determine what is the potassium content or the total carbon content or the nitrogen content of your soil just by looking at the spectral data. If you're interested in this type of application, we have on staff a chemometric scientist that is building models and will be happy to work with your samples and build some specific models for you, so you can actually see how a spectrometer can help you analyze the samples quantitatively without having to do a complete chemical analysis on it. In that particular slide, we have a a pretty specific spectral signature of soil, with specific absorption features over the 2500 nanometer range. So this sample can be taken either with a contact probe, which has a built-in light source. We have a benchtop probe as well that is typically used in the lab for this type of measurements. And the picture in the upper right-hand corner, is core logging. So for cores that are being drilled in the mine, then the contact probe is used to capture the spectral signature of those core every 12 inches, 30 centimeters or so. Another application of interest is for really spectral radiometry, where you're taking radiance and irradiance measurements. So now you're really taking direct energy measurements. You're looking at how much radiation is coming from the sun, is being reflected, from the ocean or from the ground or from a PV photovoltaic panel or from the clouds. So that is very important for atmospheric research and environmental science. And since the NaturaSpec is a spectral radiometer, that means it's calibrated to take real direct energy measurements. So it's calibrated with NIST traceable light sources here in our factory. So when you get an instrument like that, you can directly measure the intensity, the energy of a light source. Pollution, of course, is a big issue all over the world. People are using spectral radiometers for that, to get the pollution, like on snowbanks, glaciers, for instance, or in the ocean, validation of satellite data, snow and ice measurements. It's a typical irradiance curve where you will see specific absorption features in your spectral data of warp bands and oxygens and CO2 and so on. So all those bands are very important because they give you, if you have pollution, if you have high concentrations of elements in the atmosphere, it will show here in that spectral data. Spectral Evolution was founded in 2004, but the president of the company had been involved in NIR spectroscopy for many years before that. So in the end, that particular instrument is really the result of over 20 years of development and innovation in the field of NIR spectroscopy. With its resolution and sensitivity, it's really setting a new standard for field spectroscopy. And the interesting thing is, because it's so versatile, it can work for so many applications with so many accessories that it's really a great instrument for universities that may have several departments. They may have a department that is focusing on soil, but another one that's focusing on vegetation or geology or atmospheric research. And that instrument will cover all of those applications. So it's not an instrument that is dedicated to only one single application. It really reaches a huge range of application. And that's what is very attractive for this instrument, is that you can now have high quality lab data in the field for a great variety of applications. Thank you very much for attending this webinar. Again, I apologize for the technical issues at the beginning. If you have any questions, we'll be able to address those. So you can send an email to sales@spectralevolution.com. If you go to our website, spectralevolution.com, you will see a tab which is called Resources. And that resource tab has many papers, scientific papers that have been written with spectral evolution instrument data. So that will give you an idea of the variety of applications that for which our instruments are being used.